name is Green and I welcome you all to Greenview the channel. We are about to kickstart the journey on talking about ordinary differential equations, and this is the part 1 of the full series where we'll be looking at order of an ordinary differential equation. The order of an ordinary differential equation is the highest differential coefficient or the derivative in that equation. This implies that for any particular differential equation, the order of such equation is the highest derivative present in that equation. Alright, in order to understand what we imply by saying the order of an ODE is the highest differential coefficient or the highest derivative in that particular ODE, let's look at some few examples from here. Now the first question that we have here, we have dy dx plus 7x squared equals to exponential x. What is the order of this particular differential equation? Now in order to get the order of an ODE, our focus is usually on the differential coefficient we have in that particular ODE. So the highest differential coefficient or the highest derivative in that ODE is the order of that ODE, is the order of that differential equation. Now look at this question here. We have just one differential coefficient in this question, and that is the dy dx. What is the order of this dy dx? It is just 1 because it is what of the it is just dy dx. So the order is 1 from here. Dy dx is of the first derivative. That implies that the order of this particular differential equation is equally 1. Look at the second question. We have 4d squared y over the x squared plus by equals to dy dx all raised to the power of 3. Now it might look very complex, but it is a very simple question, because in order to get the order of an ODE, our concern is just about the differential coefficient present in that ODE. So our ability to recognize the highest differential coefficient, meaning the highest derivative present in that ODE, means that we can easily get the order of that ODE. If I look at this question critically, I have just two differential coefficients. I have dy dx here. Note that this power of 3 here has no implication at all in order to get the order, meaning that we do not consider the power here. Our concern is just the derivative that we have, which is dy dx, and it is of order 1. Look at the second one here, d squared y over the x squared. D squared y over the x squared actually. Now we are not concerned about the constant here, for it's none of our business. Our question here, our concern here is just the derivative that is here. And what is the order of this derivative? It is of order 2 on its own, because it is d squared over the x squared. So this is of order 2 and this is of order 1. So the order of this entire equation will be 2, because the highest order, the highest derivative that we have here is 2, which is this guy. That means the order of that particular equation is 2. Let's look at the third one. The third one is also very kind of complex when you look at it the first time, but it is also very simple, because the order of an ODE is just the highest differential coefficient. Our concern is just the differential coefficient present in that particular ODE. So we are less concerned about this 3 that is here. We are less concerned about this power of 4. We are less concerned about this square root that is here. We just need to recognize the differential coefficients present and know the highest one to be the order of that ODE. So I have dy dx here, the order is 1. I have the cube y over the x cube, the order is 3. And I have the square y over the x square, the order is 2. Which one is the highest? Of course it is these 3. That means that the order of this ODE, of this differential equation, is 3. Now let's look at the fourth one. Okay, look at the fourth one. Y prime 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 minus y prime prime plus 2 exponential x equals 0. Now y prime 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 is just another way of writing the cube y over the x cube. That's another form, over the x cube. And y prime prime is the same thing as saying d square y over the x squared. That implies that the question is same as this. Okay, so this is same as that question over there, because my y prime 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 is same thing as this, and my y prime prime is same thing as this. So to get the order of that ODE, we are just concerned about the derivatives that we have. And what are the derivatives? I have this and this, or we can say we have this and this. What is the highest? This is y prime prime, meaning it's of the second order. This is y prime prime prime, which means it is of the third order. Which one is the highest? This is the highest. That means that the order of this particular ODE, which is also the same thing as this, is actually 3. Now let's look at the next question. I have dy dx plus sine dy dx equals to ln x. Okay, the order of this ODE is just 1. Yes, because the order of this particular derivative here is 1. The order here is also 1. I don't have any other derivative in this particular equation. That implies that the highest is just 1. Whoa. Order of an ordinary differential equation, so super easy and straightforward. Can we say the same for degree of an ordinary differential equation? Anyway, we're going to find out in our next video. Do well to subscribe, like, and share this video so that we can continue this series, and you are going to see from my view. Thank you. I'm Green, and this is the Green View channel.